Hello everyone, welcome to KripAcademy. So, today we're going to be going over how to graph cubics when they are in vertex form, which is the form that you see, right here. So, what do each one of these variables represent? So, A right here, is going to represent your stretch factor, essentially, of it. So the higher A is, the skinnier that the graph is when you graph it. X is just X, because it's Y according to X. H is going to be your, is going to be the X value of your vertex, and K is going to be the Y value of your vertex. So what does this mean? That means that the point of inflection, or you can think of it as the vertex, if you will, is located at H, K. Now remember, in this formula, there's a minus here, which means that if x minus h is x plus 3, h isn't 3. H is negative 3, because it's really x minus negative 3 to get x plus 3. So if we were to just graph this equation in its most basic form, the vertex is at h, k. So let's just put a point here and say this is hk. Then you move over to the right 1, and you move up a. So that'll put you at 1, 1. Then you move over 1, and then you move up 7a. Now this is going to go off the graph, but it doesn't matter as long as we plot our point. So this point is 1, 1. This point will be over 1, up 7 is 1, 8. Or 2, 8, sorry. So that gives you the right side of the cubic graph. So now you have to do the other side. The other side is almost the exact same thing, except instead of going up, you're going down. So you go to the left 1 and you go down a. So that'll be 1, 1. And then you go to the left 1 and you go down 7a. So if we're at -1, -1, we'll be at -2, -2, -8. So that's how you graph the most basic one. So doing the same thing for y equals x squared. So a is equal to 0 in this case, or rather a is equal to 1 in this case, because it's technically right here, but you can't really see it. H is equal to 0 because there's nothing here, and as is k. So that means that the point of inflection, the vertex, if you will, is located at 0, 0, the origin. You go over 1 and up a, so that'll put you at 1, 1. Then you go over 1 and up 7a, that'll put you at somewhere up here. Do the same thing on this side, and you get a graph that looks something kind of like this. That is going to be what your most basic cubic graph looks like. Now let's apply the same logic to this equation right here. So the a value in this equation is -1, because there's not a 1 here, but a negative essentially means that. So what does that do? That essentially means that instead of going to the right and up, we're going to the left and up. and then instead of going to the left and down, we're going to the right and down instead. It just kind of flips the graph. You'll see what I mean when we graph it. Our h value is equal to 2, because remember, it's x minus h. So it's x minus 2 would be our h value. So our h value is 2. Then our k value is also 2, because there's no minus there, it's just regular, which means that our vertex, if you will, the point of inflection of our graph is going to be at 2, 2. So right here. So now we know everything that we need. So our a value is -1. So like I said, we're going to be going to the left 1 and up 1, because a is equal to 1. Then we're going to be going to the left 1 from there and up 7a. So we'll be at somewhere up here, and we'll be at 0, 10. Then we have to do the same thing on the other side. So we're moving over 1 and down a, over 1, down 7a. So 1, 2, 3, 4, 5, 6, 7 will be about right here. And this will be at 4, -6. So now we have a point of inflection, we can graph this. So we just draw a line through it, and that will give you our cubic graph of this equation. Excuse my poor drawing. So now I'm going to give you guys some problems to try on your own. You obviously don't have to try them. I'm going to go over how to do them anyway. But I figure you can pause the video, try them out. As a challenge, this one explains in words. As a challenge, this one here explains in words what you're doing instead. So this is a translation of 2, 4. Reflection across the y, stretched vertically by a factor of 3. I'll explain how to do that when we go over it. What I want you to do for this one, also give me the equation as well as graphing it. So try and come up with that on your own. Pause the video now. I'm going to start going over them in 3, 2, 1. Alright, so for this equation, we have y equals x plus 3 cubed minus 4. So we know our a value is 1, which doesn't really change much. Then we know that we're going to the left 3, because our h value is -3. Because remember, it's x minus h, which means that it's x minus -3, which is what gives you our 3 value, because minus minus is just plus. Then it's -4. So we know our vertex is -3, -4. So let's go and graph that here. Our a value is 1, so we can just proceed like normal. So we're going over 1 and up a is 1, so right here. Over 1 up 7a, so over 1, 1, 2, 3, 4, 5, 6, 7. 7a right here. Same thing on the other side. Bam. It's going to be real low down here. For the ones that are off the graph, you should label them. You should really label all of them, but for time's sake, I'm not. So this will be at -5, -12. Then you just graph it. Stick a line through it. Bam, that's your graph of that cubic function. For this one, a is -2, which means that instead of going to the right, we're going to go to the left and up. No k value, but our h is 1, because again, x minus 1. So our a value is 1, and like I said, k is 0, so 1, 0 will be our vertex. So right here. -2. So that means we're going to go to the left 1 and up a, so 2. Over to the left 1 and up 7a. So that's 14 that we're going up. So that point is somewhere up here. We'll say that this is at 0, 2. This is going to be -1, -16. Or -1, sorry, +16. Same thing on the other side. Over 1, down 2, because its a value is 2. Then over 1, down 7, times 2, because a is 2, so down 7a, so it's going to be somewhere down here. Let's label that point, so it's 3, and then we're at -2, and we're going down 14, so it's 2, -16. Draw a line through it, and our cubic graph is done. Now notice how, if you can tell with my terrible drawing, this kind of got a little bit skinnier. You could say it was stretched vertically a little bit. That explanation is going to help us for this one. So for this problem, say you're starting out with y equals x cubed. Assume that you're starting out with y equals x cubed. Always do that when you're given just something like this. Unless they specifically tell you start out with this equation. So it's a reflection across the y-axis. So what's the difference between these two? Well, in this problem here, you are going to the right and up. In this problem, you're going to the left and up. So if you reflect this across the y-axis, it will flip over. So what that really means is that you're just getting a negative a value. So after reflection across the y-axis, right now our equation is y equals -x cubed. Now we have a translation, that's what this represents, of 2, 4. So that means that we're moving to the right 2 and up 4. So let's plot our point that we're moving to here. And then let's change our equation. So we have y equals negative, and then we're going to put the parentheses now because this is going to change where our point of inflection is, our vertex, if you will. So if it's at 2, 4, we got to remember that the equation is y equals negative, or y equals a x minus h. So this is going to be x minus 2 cubed, and then 4 will be the y value of the vertex, which is h, so plus 4. So this is our equation so far. Now it's stretched vertically by a factor of 3. All that's saying is whatever a was is going to be 3 times a now. So that'll give us our final equation, which is going to be y equals -3 x minus 2 cubed plus 4. So now, graphing this, it's going to be a pain because there's a 3 there, and these things tend to get real skinny real fast. So we already know what this is. So I'm just going to do one set of points. We're going to move over 1, and because it's negative, we're going to go over 1 to the left, and then up a. A is 3, so that'll give us a point here. And then doing the same thing on the other side, over 1, down 3. And then we got a point somewhere all the way down here, and somewhere, we'll put it all the way up here. And this is our cubic graph. Alright, that's it for KripAcademy. Thank you for watching. Catch you in the next one.